Hello and welcome to assignment 8 solutions. Okay, it's just as always, if you've turned this in and you've made a good go at it, I'm going to give you an opportunity to correct. So what I'm going to do is going to go over the problems, and I've solved them in multiple ways. Well, actually, two of them are pretty easy to solve because all you're doing is just copying down numbers. But some of them are a little bit more complex, and I'll show you the ways that I solved them. So the first one, these are all kind of rate of return type of problems. And the first one, we've got a HVAC engineer, and you're building, and you're looking at a software. $500,000 an initial cost, $10,000. Okay, so $10,000 per year for 10 years, and $700,000 at the end in refurbishment, in equipment refurbishment costs. So this is significant savings. So an initial cost has the final savings of $700,000 at the end of year 10 and an annual savings of $10,000. And you want to know what the rate of return is on this is. So what you're really doing is, remember we said solving for I. Now, there's a few ways that you can do this. I'm just going to go over one method. It's a relatively straightforward method. Let's just go ahead and convert everything to present worth. And if I do that, I take the 500,000, the present worth of the 500,000 is 500,000, but it's a cost, so it's negative 500,000. If I want to take the final savings, I'm going to have to convert that to present cost. So I'm going to use P over F, I and 10. It's simple because you've got, but remember, we don't know I. So what we're going to do is we're going to come down here, we're going to put an interest number in a cell. Now, that's actually what we're solving for, is that, so just put some value in there. Good to start with 5%. I mean, if I put in a 5, it's pretty straightforward. Let's do that. Let's just put in a 5. So 5. And notice that that number there actually changed. The P over F and the P over A, those numbers didn't really, I mean, there were some values that changed because the interest rate changed, but these numbers are calculated. I just used the formulas which I gave you, P over F, P over A, because the annual savings would be P over A, final savings would be P over F, those two equations with the interest rate. Now, what I can do is take these three numbers, because remember, if we want to find the rate of return, the cost and the savings should come out to 0. And if I want to do this the good old fun way of the what-if analysis, I'm going to go ahead and goal seek. I'm going to go ahead and set this cell right here so that it goes to 0 overall cost by changing this cell right, this cell right here, and voila, it finds the 5.16. Now, alternately, if you want to use the tables, you can go ahead and plug in, let's say, a value of 6 here, using the exact same equations, P over F, P over A. Same numbers. I just copied this stuff down here, and I get this number, which is the sum, is not going to be 0. Okay, I do the same thing, let's say at 5%, because I can also, again, go and look these up at the tables. I can look up the P over F and the P over the A and the I with the I of a 10. Those are in the tables if you've got the tables. Now I know at 6 and 5, so the interpolation will be 5 plus, because notice it goes from negative to positive, so it goes, oh, so we need to find that where it's at 0, where it zeroes out. And you can do that just simply interpolating to where that 0 point is. That would be, in this case, it comes out to be 5.16, but it would be 5 plus this number over the sum of those twos, the magnitude of the sums of those twos, because it's 5 plus whatever this fraction is. And it comes out, it's not going to be exact because this isn't actually perfectly linear, but it's close enough. And it will also give you 5.16. Not too bad. You might have some other ways to go about it, but I mean, the what-if analysis was my preferred method because I know it's going to give me an exact number. Here's a pretty exact number. But rounding it to 5.16 is fine. The next question. Okay, so basically, you need $8 million. It doesn't really matter how much you need because that's not what the question is about. And so what we're doing is we're actually going ahead and they're issuing bonds. Bonds are things that you can buy and you're going to get a return on the bond. So you buy this bond And it says it's a $1,000 face value bond that will return 4% interest with semi-annual dividends. So it's actually a little bit more common because you throw in that semi-annual return period. So basically, it's a bond that behaves like a $1,000 bond, but it costs you $800. But remember, the bond has two things. It's face value and its return. So first, how much will the bond return? Well, if it's 4%, and it's usually 4% simple interest, $1,000 times 0.04 is 20 bucks. Sorry, 40 bucks. 40 bucks a year is what it's going to actually return in dividends over the course of the 20 years. So the dividend here is easily calculated by the 1,000 times the 0.04. It's a bond. However, you only paid $800 for it. So effectively, you're getting more than that 4% interest rate because you only paid $800 for it. Okay. So how are we going to calculate this out? Well, because what we really want to know is what is the actual effective interest rate that this thing is giving you. It's not, the real interest rate isn't 4%, it's actually something different. So, first let's go to the fact that it's actually 40 periods, not 20 periods, because it's returning every 6 months, so it's going to have 40 periods that it pays back. Okay? Which also means that the dividends on those 20 on that 40 is actually 20 per period. You only get 20 back per period. Now, here's what you can do. Just essentially convert everything to either present. Now, I did both. I converted, I said, okay, let's take the dividends and let's figure out the present value of those dividends. Well, the present value of the initial cost of the bond is the initial cost of the bond. It's a negative number, so negative 800. Okay, if I want to take the present value of those annual payments, I can do the P over A formula. But remember, you've got an interest rate, which we don't know. Okay, we don't know that interest rate right now. Just put some value in there because it's the effective interest rate that you're looking for. But use the P over the A, that interest rate, and then the 40 pay periods, and you can actually get the present value of the payments. And you also need the present value of the return, because when the bond matures, you get the money back. That's the beauty of it. You know that they're paying you back. It's a $1,000 bond. You get back $1,000. Okay, so because it was a $1,000 face value bond. Remember, the fact that you paid $800 for the bond doesn't mean that it doesn't you're only going to get $800 back. It is effectively a $1,000 bond that's being discounted. They just gave you a $200 discount at day one. So, I get the present value of that return. Now, it's going to also be at some interest rate. So, doing that, I can either plug and chug different interest rates, but I did the same thing I did before. I did a what-if analysis. I want this total thing to come down to 0, and then I found that that was 2.84. Okay, I also, just to show that you can do this, this was going to find present value and zeroing out the present value. And I can do the exact same thing, only in this case, I found the annualized value. So in the case of the second, and it gives you the same answer, but A over P. So the annualized value of the $800. The annualized value of the 20 bucks, well, that was easy because it's 20 bucks. It's what it returns to you each time. And the annualized value of the return, which is A over F and A over P. So you get these values here. And voila, I want to set this to 0. So I again did a what-if analysis, changing this number to that 0. Now, the rest of it's relatively easy. Once you've got this number, the nominal interest rate multiplied by, because it's semi-annual, so you just multiply by 2. Or if you want the effective interest rate, it's the formula 1 plus I, the I bar up to 2 minus 1, and there they are, 5.69, 5.77. So that's effectively, 5.77 is effectively the interest rate you're getting back based on the discount of the bond. There you go. Question number 3. A tool and die, and they want you to basically create a tabulated incremental cash flow. Now, I could have put year 1 through year 25 all together here, and if you do that, more power to you. It really, you really didn't need to do that because you can get the final numbers here pretty easily without doing that. But essentially they said, okay, this used piece of equipment, okay, cost of net of $15,000, a cost of $8,200 per year, and a return value of 5%, which would be $750. Same thing with the new, just different numbers. And so if you subtract the two, now the thing for years 125, that's 25 years it's at that. So what I actually need to sum these up, I multiplied this number, the year 1 through 25, by 25. That's why I didn't put all 25 years in there. I saw that it was the same thing each time, so the 25 years wasn't too hard to do. You could also do the exact same thing by doing this number plus this number times 25 plus this number, putting them there, doing the same thing with the new. And guess what? If you subtract this from this, the new minus used, you're going to get the exact same number. That's what I did in this cell right here to prove that the two numbers were the same. So essentially an incremental cash flow tabulation. In question 4, I wouldn't say it was more complex. It's just but one thing they did say is that they wanted you to use the least common multiple for the incremental cash flow. Well, one's got a life of 3 years and the other one's got a life of 6 years. So the least common multiple would be 6. It's nice because one was perfectly half of the other. So what you would do is you do a cash flow for the 3-year one, and then you do a cash flow for the 6-year one, and you can either do the same thing here, you sum them up and subtract, or you could do each individual. Again, it's the exact same math, it's just each individual row. So note here that in year 3, because this has 1 value and this has 3, it's actually this minus the sum of these 3. Now, why does this have 3? Well, you've still got the cost, the annual cost. You've also, you have a salvage value. Now, this is one, are you salvaging it or are you not salvaging it? The salvage value is 5,000, and you are, I mean, to me, I'm like, okay, you salvage the piece of equipment, it's got 3 years lifespan, and you buy another piece of equipment. Is it going to be $70,000 in year 3? Well, that's a totally different story right there, but those are the numbers that we have. So I have the $9,000 of the cost of running it through year 3, buying a new piece of equipment at year 3, and the salvage of the old piece of equipment. And then when you get to year 6, we're not going to salvage, we're going to salvage both of them, but we're not going to buy a new piece of equipment. That would just be starting a new cycle around. So that value ends up coming out to be $57,000 the way we did that. And yes, you are going to salvage, buy a new one. And that was what the cash flow will look like right there. So there you go. Hopefully everybody that tried this and went through this, I think question 2 was really the one that was complicated because you had to deal with that bond. But I did show you a couple ways of going about it, zeroing that thing out. And then understanding that a discounted bond is basically a bond that has a face value that you're paying a different value for. This is a pretty deeply discounted bond, but then again, it also doesn't have a great return. So, I mean, when you're looking at this and saying, is it really a good bond? Well, it's returning 5.77% interest effectively. So, it's not so bad. Anyway, that's it. Hope this helps. Okay, I'm going to give you until next week to go ahead and do any corrections you want to do, and I will grade the final one that you turn in. I will not be grading the original one, unless you only have the original one, and that is the one I will grade. Thanks.